Alright, so we are in AP Calculus. Today's date is Friday, January 10th, 1/10, 2020. Make sure your name and date are on the paper. We're talking about speed and distance today. Our last lesson of the unit, and then we do self-checks on Monday. Our objective is to do what, Stego?
Determine when speed is increasing and decreasing and find the total distance traveled.
There it is. Speed and total distance. Those are the foci, I guess, of the day. So first, speed. So if I have a graph of velocity, we know it's velocity because it says it over here. I want to analyze what's happening at very specific points. So I care about, I don't know, that time. Let's look at that time. Let's look at that time. And sure, we'll look at that final time. What's happening at all of those? Let's label them A, B, C, and D. All right, so I have obviously a positive velocity. A velocity on a graph of velocity is just height. So at this first point A, I want to know what is happening in terms of its velocity and acceleration. So come back over here to the table. I'm talking about times at A, times at B, times at C, and times at D. What is the velocity doing and the acceleration doing at A? I just care if it's greater or less than 0 or equal to 0. That's greater than 0 because it's height. And maybe we should write over here, velocity is height. And acceleration is what? Slope.
Oh, that's right.
It is, yeah. Acceleration, like F double prime on a graph of F prime is slope. So what is the slope at that point? Slope is either greater or less than 0.
Greater.
It's greater than 0. There it is. Which means if I had an imaginary point, I don't know, Z right here, my acceleration would be 0 because the slope here is 0. It's a horizontal tangent. But I'm not talking about that point. I'm talking about the next point is B. Let's give it an arrow. Velocity and acceleration. Tell us.
Velocity is greater than 0, acceleration is less than 0.
Good. Claire, C. And then Sego's going to do D.
Less than 0,
Less than 0. And Stego D?
equal to 0?
Equal to 0 and... Ooh, careful. Slope. Well, I guess it's not continuous. Let's pretend it went off like that. Greater than 0. Perfect. So this is where we have to get the conceptual idea of what speed is. And we're going to walk around a little bit. So let's see if Mr. Sindel can follow this graph of velocity. I start with no velocity. And then I get faster and faster and faster and faster. And then I slow down. So right now I'm slowing down. And eventually I'll have no velocity. Boom. Now I'm going to have negative velocity because I've switched directions. Whenever I cross through this t-axis, I've switched directions. So now I'm walking backwards, faster and faster and faster and faster, and then I'm slowing down gradually.
Forward.
So again, all of this, track what I'm doing on this graph. See if you know what I'm doing. I start at 0. I'm walking slowly, faster, 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 and then slowing down, and then switching directions, and I'm getting faster and faster and faster and faster, and then I'm slowly slowing down to stopping, and then maybe a little bit more backwards, forwards. We're all okay on what's happening?
Yes.
Let's analyze that in terms of speed now. Where am I speeding up? All right, here we go. We're speeding up right there on the initial point. So it has to do with velocity and acceleration, right? Well, you don't know that yet, but I'm going to tell you it's velocity and acceleration. Notice that in this segment for A, my velocity and acceleration are both the same sign. They're both positive. And then all of a sudden, right here, so that I'm getting faster and faster and faster, and now I'm slowing down. Yet my velocity is still positive. So my speed now is decreasing. Why is my speed decreasing?
Your speed is increasing because you're crossing because it's going to 0. It's back at 0 point.
At point B, I've now increased really fast. I need to slow down before I turn around. I'm slowing down because at point B, my velocity and acceleration are different signs. At point B, while yes, I am positive velocity, I'm trying to slow down to get back down here. I'm trying to slow down. I have opposite signs again. So I'm going faster and faster, speeding up, and then slowing down, even though I'm still going forwards, and then I switch directions. Okay, now I'm right here. I'm right at this intersection. I'm now going to go backwards, and I'm going to speed up. My speed is now increasing, and then it's going to decrease. Why is my speed immediately increasing when I start going backwards?
Because both of the signs are
Exactly. Both of the signs are the same. At point C, both of my velocity and acceleration are the same sign. So I'm going to speed up. But then once I speed up, I need to not crash into the wall, and then I need to slow down again, which means that my velocity and acceleration have the, right down here, I guess if I had some point D right here, right between C and D, I need to start slowing down because I have opposite signs yet again. So the main takeaway here, speed is increasing, this objective, speed is increasing when I have velocity and acceleration having the same signs. So A and C, speed is increasing. Let's pretend that we move D over here so I can talk about B and D. My speed is decreasing because I have opposite signs. All right, so, and by the way, speed in calculus, we don't care about negative or positive. It's kind of like the, it's velocity, right? Velocity is always positive, and then your direction will change. Your magnitude is always positive. So how do we say always positive in calculus or in math in general? Absolute. Yeah, absolute value. We just say, hey, take the absolute value of whatever velocity is. That is the definition of what speed is, because, well, I guess it's kind of like the magnitude, right? Magnitude and direction of velocity. So the speed is just the absolute value of velocity. You'll never have a negative value for speed. I'm just going backwards at a speed, forwards at a speed. All right, so speed is increasing. How do I say that with V and A? Speed is increasing when signs of V and A are the same. So V and A, same sign. Have same sign. And speed is decreasing when V and A
They have different signs.
have different sign. I'm going to abbreviate DIFF for different sign. Cool. Hopefully I met the first part of our objective. We don't have a backside to our note, so I'm now doing the second part of our objective, total distance. So, is this going to be the same graph? No, this is a different graph of velocity. It's still a graph of velocity. So now you think of Mr. Sandell or whatever your particle is. It starts off with immediately very, very high speed, and then it changes direction to go backwards, and then it changes direction again and goes back forwards again at a very high speed. Well, if I did this calculation on my calculator, I would have, in terms of position, I would have a total positive position change because that's a positive area. Do we all agree? Let's say that let's just make up a number. Let's say that's positive 8.
Okay.
Let's make up a number down here. Do you think that's bigger or less than 8?
Bigger.
Bigger? Okay, so negative what? Make up a number. Negative 5. And then this area over here, it looks about symmetrical, so I'm going to call that 8 as well. So, how far did I actually travel? If I actually look at time equals 3, do I just add 8 and 5 and say, oh, you've traveled a total distance of 3? Because 8 minus 5 is 3? Think about someone who's moving forward. Let's say I start here, not on this graph, a totally different graph. I move forward a positive distance, and then I move backwards the same exact distance. How far have I traveled?
0.
My total net distance is 0, but my total distance traveled
It's twice.
is
Like
that and back. I just add them up.
So you add the absolute values.
Add the absolute values of your areas.
And that's distance.
That's total distance traveled. Total distance traveled, take the absolute value of each of these areas, add it together, that's the total position. Sorry, that's total distance traveled. Total position change. My position has not changed. I went forward and then I came back to the same spot. My position has not changed. I'm still here. But my distance, I have traveled some distance and I traveled even more distance to get back here. That's the difference. Position versus distance.
The
Right.
position in this graph would be like 21.
Just between.
Exactly. So total distance traveled is 21. But how do we say that in terms of an equation? Because it's nice to say, oh yeah, the answer is here. But is there a general way that we can say that? So if I talk about area underneath the curve, or if I talk about total position change, this is a definition that you know from Unit 7. Total position change, total change in position from 7-1. What is the definition of that? It came after integrals, so you probably have an integral in there somewhere. Unit 7 is after Unit 5. The integral,
Oh, is that the start position plus the integral?
in order to find the end position, yeah, you need the start plus change. I'm just asking change. What is the change? 0 to 4 of vt, dt. And this is just something that's kind of a review at this point. If I take the integral of velocity and I find all of these together, that is my total position change. It's just a definition that you need to have memorized. Total position change is just integral. Done. Slightly different with total distance travel. I'm still going to have an integral. I still need to find the areas of these. Integral states I'm finding the area between 0 and 4, but not velocity anymore. Well, kind of velocity. You have to do what to velocity to make it sure it's always a positive number. Absolute value of velocity. And you do have to break this apart into 3 different integrals because otherwise you'll get messed up. So you have to do absolute value from, if I'm being very formal about this, I would have to say the total distance traveled is really the integral from 0 to 1 of absolute value of velocity dt plus the integral from 1 to 3 of absolute velocity or absolute value of velocity dt plus integral from 3 to 4 of the absolute value of velocity with respect to t dt. So this is kind of the shorthand for doing it, but when you actually do it on the calculator or like by hand, this is the full formal way of doing it. Whenever you have a crossing of the x or t axis, you need to split up your integral because otherwise you'll get a mistake, right? The calculator doesn't know that I'm supposed to stop right here and think of the absolute value of this. Well, it can if you're smart about how you do it. I'll teach you the shortcut if you want, but I don't want you to memorize too many rules, so if you just break up the integral, it will 100% always work. So the answer here, let's actually find them. If I do total position change, 8 minus 5 is 3, 3 plus 8 is 11. So I'll write 8 minus 5 plus 8 is equal to 11. If I do the total distance traveled, it's going to be 8 plus the absolute value of negative 5 plus 8, and as Gio said, that's 21. Oh wait, 23, right?
Yeah.
That's 20.
16 plus 5, yeah, it's 21.
Yeah.
All right. We're good? We're okay?
Wait, can we go down to not to
I think it's time to show you a cool little trick with your calculator. So everyone have your calculators ready? Pull them out. I want to show you what this looks like graphically. So I want everyone to graph a sine wave. So file, open recent. Oh, actually, I think I got my new calculator working. I was playing with it last night.
My battery, so it's recommended to charge.
Yeah, see, every single time you turn it on, it'll tell you that, right?
Wait, so the keypad is separate from
I'll fix it eventually, but yeah, it's really weird to try to set up this calculator compared to the Wabbit EMU. All right, so on the old calculator, I need a, oh my God, it really does that? That is really annoying. Hold on. Let's see if okay, I'm just gonna not do this again. I thought it was set up, but it's apparently not. So graph a sine wave, just do sine of x. And then let's do a window between, I don't know, negative pi. By the way, pi is shift power underneath clear, shift pi, from negative pi to pi.
Where is pi?
It's right above the division symbol. You have to do second power of. It's right there. So go from negative pi to pi and then zoom 0 it. You'll notice that it does a cool little wave.
I did error.
Did you do a negative sign or a minus sign?
Minus sign.
You have to do a negative sign.
I did never sign.
Left of the enter.
So it's negative pi, right?
Right.
2 pi.
Negative pi to pi, yeah. So you should get a graph that looks like this, yeah?
Yeah.
If you have a newer calculator, I highly recommend going and changing this to a separate function, but I'm going to do the absolute value of this function. How do you do that? Math, and then it's ABS, so I think it's under number. Math, write 1. So go under the number menu, absolute value. ABS means absolute value. So again, I went in y equals, I did math, right, enter. Absolute value of, and then you can do a function. In this case, I'm going to be kind of cool and do vars, right, enter 1. I'm going to take my y1 function, which is the function right above here. I'm taking the absolute value of whatever this function was up here, and I'm going to not graph my y1 function. So I'm going to come back up here, hover over the equal sign, and hit enter. So I'm not going to graph the old function. I'm only going to graph the absolute value of that function. I don't need to hit zoom 0 again. Well, in fact, it's better to not. I'm just going to hit graph instead of zoom 0. Only hit graph. Check out what happens.
That's cool.
Everything is the absolute value. It kind of like bounces off of it. It's like a barrier saying, no, you may not be negative. You shall not pass. And you can use this trick for any function that you need to find total distance traveled. And then do the, okay, now I'm going to do second, calculate 7. I'm going to take the integral from negative pi to pi. And hit enter, and then it'll be like, oh, yep, calculating the area, and it'll go, all of that, and it'll do positive area now. You'll find the total distance traveled instead of total position change. And the answer is 4.
Wait, can you repeat that? Like I just lost it.
All right, so once again, in the y equals, to find this new function, its absolute value of y1. Did you get that yet?
So for that, you go math and right, and
Let's
then
do this.
the first one, right?
So math, right, enter. Absolute value. And then to do y1, you do vars, right, enter 1. Or enter.
Wait, well, how do you do that one again?
So vars, right, the y variables, and you do a function, so enter. And then the y1, you choose the y1.
Okay, and then I just graph it?
And then, yeah, graph it. Just hit the graph button. Not zoom 0, but just graph.
Alright, then you know.
This is really nice because the functions are in different colors.
I know, yeah. That's why I'm like, if you have a new calculator, you can just not undo the other one. You can see the old one. Yeah.
I did it wrong for some reason because it went like that first and then like the
Oh, no, yeah, you're good. Cool. So that's all I have for you guys. Let's go ahead and start on the homework.